Okay, so in this next segment, we're going to do examples of ANOVA, and we're essentially going to lead into the full test from beginning to end. And right now, we're just going to walk our way into the deep end. So let's go ahead and take a look at the first example, and let's test the claim that at least one population's mean weight of tomatoes produced by each condition is different. Recall the p-value is printed on the ANOVA analysis. So before we even go to the analysis that's printed, let's go ahead and just go through the 4 steps, okay? So the first step would always be to set up the hypothesis. So the hypothesis is that the means are not different. Right? And the alternative would be at least one mean is different. Okay, and then we're testing the claim that at least one population mean weight is different. So the claim is the alternative. So we have to mark that. The second part would be to identify an alpha. So let's go ahead and identify an alpha. They don't give us an alpha, so we like using that 5%, right? So let alpha be 0.05. The third step is always to calculate that p-value. Okay, so this is the point where we'll go ahead and go back to the ANOVA analysis that was given to us regarding the tomato plants. Okay, so here's the tomato plants in the 5 different types of coverings, and we saw that the p-value was 0.02479. Okay, so the p-value from the other page was equal to 0.02479. And that is, our alpha was 0.05, and so that is less than our alpha, and therefore we have to reject the null. So if we reject the null, we can X out the null, and we have to accept the alternative. Since the alternative was our claim, then is there enough evidence to support the claim? And the answer is yes. So now, in the last step, we could say there is enough evidence to support the claim that at least one of the weights of tomato plants is different. And so that's really how the hypothesis test goes. You just set up your null and alternative, select an alpha, and then obtain a p-value. Now, it looks very simple once they give you the p-value, but remember there's so much preliminary work. So now let's go ahead and go try this in the calculator. So your ANOVA function is in the calculator, and so you'll enter your list in, list 1 and so on. Press stat test ANOVA, and then you're going to have to put the list in yourself. So if I go over to the calculator and go to stat, hit test, and then hit up, you'll see it's H, the very last one. And so if you hit enter, you can see that it's so bland. It's not prepped like the other tests that were in the calculator where it asks for certain things. This one is very raw, and so we just have to enter the list as we see them. And so if I go to the penny example for the weights of pennies, and they tell me to test at the level of 0.01, let's test the claim that at least one of the mean weights is different from the others. So this is example 13.2, which is the pennies, which is right up here. And we had 3 years of pennies, and then we went ahead and just saw, like, to verify the requirements for any hypothesis testing with means. And so that was verifying population parameters, and then we have the ANOVA parameters. So we already know that this sample satisfies all ANOVA requirements. So let's just go ahead and enter those lists into the calculator and run an ANOVA test. So the first thing we'll want to do in step 1 is go ahead and set up the null and alternative. So the null is we have 3 means from 3 different years, so meaning none of the weights are different from any of the years. So the mean from 1990 to 1995 to year 2000, the weights are all the same. The alternative would be at least one mean is different. Okay, the second part would be to identify the alpha, and they give us the alpha to be 1% or 0.01. The next part would be the p-value. So the p-value here would be, the first step would be to enter data in a list. List 1 to list 3. Then you can run the ANOVA test on the 3 lists, and then you can get the p-value. Okay, so let's go ahead and go to the calculator, and let me clear this and go to Stat and go to Edit, and go ahead and pause the video if you haven't entered the penny weights yet. But I have entered all the penny weights. The first list is 1990, the second list is 1995, and the third list is 2000. So again, if you have to, pause the video and go ahead and enter the data into your calculator so you can follow along. Okay, so now that I have it entered, I would hit second quit. I would go back to Stat and go to Test, hit up to get ANOVA, hit enter, and you enter the list with a comma in between. So I would hit second 1, comma, second 2, comma, second 3, and then close the parenthesis. So let me go ahead and drag that setup right here. And then if I hit enter, a bunch of stuff comes up. So let me drag this window over here. And notice it has a little down arrow, so let me hit down. And then I'll drag this all the way over here, so we have all the windows in our notes. Okay, so notice that here we have the factor. Right, remember the SS and MS? So this is going to be the one that talks about like the differences between the samples. The next one, notice the error, and it has SS and MS. Notice that's still there. That's going to be the within samples. So go ahead and compare to that ANOVA analysis that we had in the tomato example, but this information is also in there, but your calculator does all the work for you, which is really nice. And so above here, we could see the F test statistic and the p-value. Okay, so the p-value from the calculator, we get to be 0.3419. And if we compare this to the alpha of 0.01, we can see right away that this p-value is much greater than that. And when the p-value is greater than the alpha, we do not reject the null, right? And so if we do not reject the null, then we have to reject the alternative. And notice the alternative was the claim. So if we rejected the alternative, which was the claim, is there enough evidence to support the claim, right? And no. So the last step would be, in this case, to say that there is not enough evidence to support the claim that the average weight of pennies differs from each year. Okay, and so I just want to, in this example, I just kind of want to quickly show you how to, what the graph would look like. So if I had the x-axis here, remember the F distribution is right-tailed. So it looks like this, right? Okay, and so the alpha is 1%, right? And then here's the critical value, F sub alpha. And the p-value is 0.3419, which is, I would say over here. Here's the p-value, right? Which is that 0.3419. Now, the F test statistic is the one that coordinates with the p-value, which is F sub 0, which is the 1.1127 right here. And so I just wanted to make sure that you saw that this is what it would look like. It looks similar to the chi-square, but it's not its F distribution. But it's similar idea where here's the critical value for alpha that corresponds to alpha, and the p-value corresponds with the F sub 0, which is the test statistic, which we get both from the calculator.